Hello friends, today's question. Consider the LR circuit shown in the figure. If the switch S is closed at t is equal to 0, then the amount of the charge that passes through the battery between time t is equal to 0 and t is equal to L upon R is. So we are given this LR series circuit and we have to find out the amount of charge that passes through the battery E. So in this case we are going to find out, or rather we are going to start with the current, and then we can easily convert that to the charge because current is equal to dq by dt. So the equation for the current is quite standard. So we can say that the current in the circuit, if it is represented as I, and this I will be equal to I naught 1 minus e raised to power minus RT upon L, where I naught is the maximum current and this I naught can be written as battery voltage E divided by resistance, and the rest terms will be same. Now we can write this current as dq by dt. So we can just modify the equation that this will be dq by dt and E upon R 1 minus e raised to power minus RT upon L, which we can further modify as dq E upon R 1 minus e raised to power minus RT upon L multiplied by dt. We are going to just separate the variables now. So we can write this as dq is equal to E upon R times dt minus E upon R times E minus RT upon L times dt. And we have to find out the charge for the time that is between 0 and TL by R. So we can integrate it. So therefore we can say total charge Q is equal to integration of dq, which can be further written as 0 to L by R. We have this ER dt minus 0 to L by R, and here E by R can be taken as common. So this is from E minus RT upon L multiplied by dt. Now it is quite straightforward. First part, in this part, will be giving us E upon R, and here we have upper limit L upon R minus 0, and the second part will be giving us E upon R, and this will be equal to E minus RT upon L and divided by minus R upon L. The limits are from 0 to L by R. So we can write this as E upon L square minus, and this comes as minus minus will be plus, so this will be EL upon R square. Now we substitute the limits, and upper limit is upper L upon R, so this becomes e raised to power minus 1, and second is 0, so this becomes 1. So the charge Q will be equal to, we have this as E upon L upon R square plus, we open the bracket and multiply it. We can write this as EL upon R square e raised to power minus 1, and this will be minus E multiplied by L upon R square. These two terms cancels out, and we are left with only one term, that is E upon L, E minus upon R square. So we can just modify it. We get Q is equal to E upon L upon exponential function and R square, and we know the value of exponential function is close to 2.7. So this gives us the total charge Q will be EL upon 2.7, and this will be R square. So this is the amount of the charge from T is equal to 0 to T is equal to L upon R, and this gives us that the option number B is the correct option. Option B is correct. So this completes the